two pairs of parallel sides. AB is parallel to DC and AD is parallel to BC. Opposite sides have equal lengths. Therefore, AB equals DC, AD equals BC. Opposite angles are equal. Angle D equals angle B and angle A equals angle C. The diagonals of a parallelogram bisect each other. It means that AE is equal to EC and DE is equal to EB. AE, EC, ED and EB. The sum of any pair of two consecutive angles is 180. Now, let H be the height of the parallelogram and let B be the length of side DC. Since a parallelogram is formed by two identical triangles, this one and this one, in terms of B and H, the area of a parallelogram can be calculated as the area can be calculated as 2 times the area of a triangle, half the base times height. Finally, the area of a parallelogram is base times height. A rectangle is a parallelogram with all angles fixed at 90 degrees. All properties of parallelograms apply to rectangles as well. The area of a rectangle can be calculated as base times height, and the diagonal can be calculated by using the Pythagorean theorem. Let D be the diagonal. According to the Pythagorean theorem, D squared equals A squared plus B squared. Finally, the diagonal is the square root of A squared plus B squared. A rhombus is a type of parallelogram with 4 equal sides. Side AB is equal to side BC to side CD to side AD. The diagonals of a rhombus are the segments that connect two vertices of the rhombus opposite angles, diagonal AC and diagonal BD. Now, let capital D be the length of diagonal BD and let D be the length of diagonal AC. The area of a rhombus in terms of the diagonals can be calculated as half the product capital D times D. But also remember that the rhombus is a parallelogram. If I draw the rhombus in this position, the base is M, and let H be the height. Which of the following represents the area of a rhombus in terms of M and H? So, the area of a rhombus can be calculated also as the base times the height, just like the area of a parallelogram. A square is a parallelogram with all sides equal to each other. All properties of parallelograms apply to squares as well. Let A be any of the sides of a square. Then the area of a square is A squared. The diagonal of a square is this line. Let D be the diagonal of a square. Notice that the diagonal divides square into two identical triangles. and these triangles are both a right special triangle of 45 and 45. So, according to the proportion of a 45 and 45 right special triangle, the measure of D is A times the square root of 2. If you don't remember the proportion, you can find the value of the diagonal by applying the Pythagorean theorem. D squared equals A squared plus A squared. D squared equals 2 times A squared. Finally, D equals A times the square root of 2. A trapezoid is a quadrilateral with only one pair of parallel sides. Side BC is parallel to side AD. Now let H be the height of trapezoid ABCD. Let B be the measure of side AD, and let A be the measure of side BC. The area of a trapezoid can be calculated as height times the average of the parallel sides. Now, for an isosceles trapezoid, the base angles, in this case angle A and angle D, are equal, and therefore the left and right side lengths are also equal. Side AB is the same as side CD.